The Time-Sensitive Mechanics Project. This project allows a user to set a timer that, when up, causes a servo motor to make noise, alerting them. The circuit is comprised of four parts: control with the Arduino Uno, timing with the DS1307 RTC, display with an LCD, input with two momentary push buttons and a slide switch, and output with a micro servo. The accurate timing is done by the RTC. A 1 MHz square wave signal is outputted on its square wave pin and fed into interrupt pin 2 on the MCU. The RTC and the MCU communicate via the I2C protocol using the wire library. The RTC needs to be configured to output a 1 MHz square wave, as it has many other modes that can be set. To do this, in the setup section, its control register, register 7, is accessed. The wire library begins to communicate with the RTC by pulling the data line from high to low when the clock line is high. The transfer is then done by the master to the slave. The MCU sends a value of 7 to enter the control register, followed by a stop condition by pulling the data line from low to high when the clock line is high. The slave then sends back an acknowledge bit to confirm the data was transferred correctly. The master then sends the value in binary MSB first 0001 0000 to set the register so that the clock outputs a 1 MHz square wave, based on the information in the datasheet. The fourth bit is the square wave enable bit and is toggled high. The final two bits, RS1 and RS0, are both set to 0 to set the frequency to 1 MHz. The slave acknowledges the transmission and then the communication between the devices is terminated. Interrupt pin 2 monitors the falling edges of the square wave that happen once per second. The ISR triggered by this decreases the count by 1, assuming the pause switch is off. The default start time is 5 minutes. The user can increase the time by 5 seconds by pushing the first button, and decrease it by 5 seconds by pushing the second. The time remaining is split up into seconds and minutes by dividing by 60 to get the minutes, and the remainder is the seconds to display, using the mod operator. These values are displayed to the user via the LCD display, connected via the white wires to the MCU, as defined at the top of the code. Finally, when the time is up, the display notifies the user and the servo motor begins to turn and strike a nail against the bell or other surface, creating a loud noise to certify the timer is up. This is done using a PWM signal, not the servo library.